Hey there, in this lecture we're going to talk about another crucial concept in object orientation known as abstract classes. Since you've already covered interfaces, understanding abstract classes should come somewhat natural to you. So let's get started. An abstract class is basically almost a regular class. It can have methods in there, it can have method bodies in there, but the key word here is abstract. And from creating that interface, remember what that method was. It was an abstract method. So an abstract class is basically almost like a regular class, except that it has abstract methods in it. And an abstract class can only be extended. You cannot instantiate an instance of an abstract class. It's only meant to be a parent of another class. So let's try an example. I'll demonstrate to you how we can use an abstract class. If we look at animal, let's click there. Notice that it has some general behavior. Now we can define another type of general behavior in here. And look, I didn't give it a body, and it's going to complain that we need to either add a body or add abstract modifier. So when I click that, now it's going to require us to make this class an abstract class because it has an abstract method. So hover your mouse over it, it's saying make type animal abstract. So with that abstract modifier added to this class definition, any class that extends this class or is a child of this class is going to need the move method implemented, right? Because we're not implementing it in this class, we're just creating an abstraction for the idea of moving. And this class doesn't tell a particular animal how to move. A fish can swim and a bird can fly, or a chicken can walk. So these are different types of movements based on how an animal moves. So that's why we didn't give a specific implementation in here. This allows for abstracting away the idea that one animal moves differently than another. And notice that we would never really even have to create an instance of animal. You can never create an instance of an abstract class. Abstract classes are used for inheritance, all right? This is usually a parent class and expects child classes to implement the abstract methods. So let's take a look at fish first. Notice that there's a little error here. If you hover your mouse over this, it's saying add unimplemented methods, all right? So when you click on that, notice that it added on the bottom the move method. And by default, this annotation of override is placed by Eclipse. You don't even need that, so you can get rid of that for now. And for this movement, I'll just print out that the fish is swimming. And for the bird, this is also going to require us to implement the move method. So when you hover your mouse over it, add unimplemented methods. So I can basically just write this. I can say flapping wings, right? Just because the bird is flapping wings doesn't mean he's actually flying or walking. It is a move method. It's a general method for moving. So this makes sense here. So now back in the zoo class, if I want to, for example, sparrow is inheriting from bird. If I want to make sparrow move, look at what it's going to say. So I'll create an object of type sparrow. And we have to obviously give it the proper arguments to construct a proper bird. And now we can ask sparrow to move. And when I run this, notice that the sparrow is flapping the wings. Look at what I can do here now. I can put animal as the type for this variable. Now the object is created someplace in memory. The object is not of type animal. The object is of type sparrow. but the variable that points to that object is of type animal. And remember what I said in the previous lesson, that variables, the methods that we can invoke on variables are based on the type specification. So sparrow1, if I want to make sparrow1 fly, I can't do that now, right? The fly method is not part of the animal specification. I can only call higher level methods such as move, right? So that's an important point. Keep that in mind. I'm going to make this back to Sparrow, and now it will have other methods. For example, fly is there, and of course eat and sleep are already being inherited by this guy. Now I can make the fish move as well. And fish1 dot, we can make it move, and notice how the fish moves. When I run this, the fish moves in a different way, right? So let me change this back to move for sparrow. All right, so now the sparrow is moving and the fish should move. So when I run this, look how the sparrow moves and look how the fish moves. Now you may be wondering, if we have to create the move method in the sparrow class as well as the fish class, what's the point of having that method in the abstract class? We could just write these methods in the actual child classes themselves. Well, here's the beauty. Take a look at this. I can make this an animal type, and I can make this an animal type. They are both animals. Fish is an animal and sparrow is an animal. And through their type specification, through the animal type specification, I can invoke the move, and same goes for the fish. That is also of animal type specification. But the actual object, when the application runs, the actual object's behavior will be different, because this object is actually a fish and the sparrow is actually a sparrow. And this allows for making things more dynamic and generalized. For example, if I want to create a method in the zoo class, let's create another method, and this is going to be a static method, move animals. All right, we want to move animals from one side of the zoo to another, for example. In here, I can just give an argument of type animal. Oh, and I need to have a return type here. Now all I have to do is call animal dot move, and this method, this particular method called move animals, works for any kind of animal. All right, so I've created an object that is a fish, right? Its variable type is an animal, but the actual object that's created in memory is the fish, right? So you want to be thinking in terms of runtime. This application is running line by line, and it's bringing to life objects that will behave dynamically. Let me call this method, and I can just pass in fish1. I can pass in the sparrow. So if workers in the zoo want to move animals from one place to another, for example, they just call on the animal and say move, and the animal, the actual object, will already have the knowledge on how to move, because the object that's been created in memory is a sparrow object, and we're just using this as sort of a way to organize our code. It's an instance variable, and this variable knows exactly where the object will be created in memory. So when we pass this variable around to methods like this, since it's pointing to the actual object, it can tell that object to move or do things, and that object will know how to act, because the object is of type sparrow. I mean, it's a sparrow object. It knows exactly what's in its class definition. It will know how to move. So remember, in this method, we are passing in the variable. Right, we are passing in fish1, which is an instance variable. We are passing in sparrow1, which is an instance variable that is pointing to the object that will get created when we run this application. All right, I'm going to put, again, the emphasis on running this application. When the application runs, that's when all of this sort of gets wired together and these objects come to life, and you reference these objects through this particular variable that will know exactly where the object is located in memory. All right, so hopefully this makes sense. And if it's a bit confusing to you right now, that's totally fine. You're going to be seeing this a lot more as we progress in the course. So let me comment out both of these. And I'm going to run this, and I expect both of these methods to be executed. And notice it's working as expected. The fish is swimming, and the bird is flapping its wings. I created this method called moveAnimals for a special reason, and that is to highlight to you a very, very important topic in object-oriented programming, and that is polymorphism. If you look at the definition of this method, notice that it's just representing the general idea of an animal being able to move. And the parameter that this method has is of type animal. It's a parent type. So all of its children can also be passed in through the same method, right? This method can be used to move all different kinds of specific animals. Right now we have fish and we have birds, but we could have had so many other animals in our zoo, such as snakes and toads. Toads would move in their ways. Snakes would be able to lurk around in their own way on the ground, and so on, right? This is called polymorphism, and it allows for making your program more dynamic. So if it's a little confusing for you right now, don't worry. You're going to be seeing this a lot more, and trust me, in just a few lessons, you'll have this concept mastered. A small modification I want to make is I want to make this a singular method. Right now it's saying moveAnimals, but we're only passing in one animal at a time, so just a small design consideration here. So I want to discuss something else now. Let me clear out this main method. Flyable is actually a type. And what did I say about variable types? We can actually create an instance variable of type flyable. And I'll call it flying bird is equal to new sparrow. Notice what I'm doing here. I'm saying that this instance variable is going to point to an object that is going to be the sparrow, but its type is flyable. So what methods do you think this particular instance variable will have visibility to? Can you take a guess? Let's see. Flying bird dot. I see fly in there. Do I see any other methods? No, that's it. That's the only method that it has visibility to, because remember, what is its type? Its type is flyable. What is the specification? If we click on that, it just has one method in there. So this is the only method that will be visible, all right? But notice something. If we go back to the zoo and I initialize another variable, and I say bird, I pass in the arguments to create the proper bird, it's not going to work. Can you guess why this is? If you hover your mouse over this, it's saying type mismatch, cannot convert from bird to flyable. All right. Now, I have a question for you. Is bird really a flyable? The only way you can find that out is you look at the class definition. So let's look at what object is going to be created when we try to initialize a bird object. If we click on the bird, notice that it extends animal. It's not implementing flyable. And if we look at sparrow, sparrow is implementing flyable. All right, so when we define a type here in the zoo class, when we're defining a type of flyable, and we say that this variable is going to point to an object, that object better implement or inherit or be an implementation of that particular type. Right? Sparrow implements the flyable interface. The bird does not implement the flyable interface. And during compile time, our editor is smart enough to tell us that we cannot instantiate an object of this type that is pointed to by a variable of this type. Okay, so this variable, its type is flyable, and we cannot reference an object in memory that is a bird, right? Because that bird is just not flyable. All right, so there's a lot more we can talk about, but I'll leave that to the remainder of the course, in which I think you'll have a smooth transition once you practice these concepts. And there's a lot more to learn in this course, and I'm sure it'll be a wonderful experience for you. Do all of the practice assignments, and I wish you the best of luck.